Okay, folks. I think this is it. I give me an update to audio and video. I think this is it. I hope everything works. I hope you can hear me. I hope you can see me. I hope the software and the hardware don't give up on me, and you please need to give me a feedback on audio and video quality, if you can hear me well, if everything's okay, before we start this session. Hi Nikhil, hi Darko, hi back again, nice to see you. Hi Christian, hi Osama. Is audio and video fine? Linnea, hi. Cool, okay. Audio and video seems to be okay, then let's go. What do you see here? You see my Planetarium software, Stellarium, and this is my backyard, my virtual backyard. I did a video on how to incorporate your backyard into Stellarium, and this is the software through which I basically control my telescope. So I'm in the position of my telescope right now. This is the shed of my telescope over there, and I just need to carry the telescope outside. I need to polar align, focus, turn everything on. Polar alignment actually needs a little bit of time, and then I can connect Stellarium to my telescope like I did here and do all the controlling from here. So let me have a look. Yeah, software is running, and so what we're gonna do is we want to observe different objects in the night sky. Last time we did a live session together, we did planetary imaging, and this time we want to do deep sky object imaging. That means we image objects far out our own solar system, and thereby I use another camera. I don't use my planetary webcam, but I use my DSLR camera. The DSLR is from Canon, and it's Astro-modified, and we're gonna use that camera to capture some deep space stuff together. Great. The idea behind this is that I use something called live stacking, so I can take short exposures of stuff, and then we incrementally see the object's quality increase over time while watching the different targets. So we don't need to spend like half an hour before we see a result, but we can see pre results, let's say like that, and they incrementally increase in quality as we stay on the target. And I've never done that before in live streaming, so I hope everything works, and it's, yeah, let's just see. But first and foremost, we need a first target, and I think we should move through the universe in steps. So we don't image something within our solar system, because planets and moons, that was for planetary imaging, that was last time, and now we want to move outside of our solar system into the void, into the darkness of the universe, and image something far behind that. Okay, and so we want to get a first glimpse of some nebulosity, and this is the great stuff here. You can just click on anything like this. This is a nebula. It's the North American Nebula. Actually, I selected a star within the North American Nebula in Stellarium, and we want to say current object, and I choose I choose a part of the North American nebula which is very rich in contrast. And so those nebulas are within our own galaxy. So the galaxy is a collection of stars, like 300 or 200 billion stars clustered together around a supermassive black hole. And those nebula are the stuff from which stars are made. Helix nebula or ring nebula. Okay, you know what? I will create a list because those are great targets as well. We're gonna see. Helix, ring nebula. Both of them, Helix Nebula and Ring Nebula, are within our own galaxy as well. But first of all, we need to slew our telescope to the North American Nebula. I'm going to take a test exposure to verify that we are on target. Okay. I need to reconnect the camera, sorry. Wait a second. I don't know why. Excuse me, I just needed to reconnect my camera. Then I can take a test exposure. And we can and then we can use something called plate solving to figure out where we are in the night sky. And then we can start taking images for live stacking. So right now I'm using different pieces of software to do all the tricks, and I really need to combine every part to one final piece of software. So we're there, that looks good. We need to delete the old images from this folder because we want a live stack within this folder. We don't need any crap in there. And then we can take a simple plan. Nice plan. And we say take 60-second exposures. Exposure length 60, ISO say 1600, pause is 5, count 500, I don't know. In RAW. There's a new plan, and then we simply start the plan and start the live stacking. So first of all, we need to wait like 1 minute for the first image to appear. And if that works out, I try to decrease the exposure time, because all along we're doing live stacking, and while doing live stacking we can deal with shorter exposures and just add all them together. So Charles suggests that we keep it within our galaxy and then next time do a separate session outside our galaxy. That is actually quite an interesting idea. Okay, you want to see the Comet Pan-STAR. Why not? I set it on my list if I can see it from my backyard. I don't know. What am I adjusting now? Wait a second. So this is Deep Sky Stacker in live stacking, and it's quite a bit overexposed. Whoa. Okay, so this is live stacking. That means that I try to get the the stretching on a fair amount. It doesn't look too cruel. Yeah, I think this is, for a first image, it's okay. So here you can see parts of the North American Nebula. It's a bit overexposed here, or let's say overstretched with Deep Sky Stacker live stacking. But you can see those different nebula regions within this image, and the high contrast regions we saw before in Stellarium. And so I'm coming back to your questions before saying something about this image. My camera is a Canon EOS700D Astro-modified. That means, especially for this target, this is a nebula shining reddish in the H-alpha spectrum. So that means there's a lot of hydrogen gas out there, and the bright stars within this nebula energizes that gas, so that the electrons shift to a higher energy level, and when falling back they emit a very specific wavelength. And while emitting this very specific wavelength, they have a very specific color, and we can pick out this color. I astro-modified my Canon camera because normally there's a filter in front of the camera sensor to eliminate some of the redness that the camera would normally detect with its high sensitive filter. But for astrophotography, we're mainly interested in those reddish emission lines for the reddish nebula, and so I removed that filter, or had it removed by an expert, in order to the camera to be much more sensitive in this reddish emission lines of those nebula. So I try to readjust the stretching just a little bit, yeah, something like that. You can see those high contrast lines down in the bottom, and this darker region in front, in the central region. Yeah, and those nebula are actually quite huge. Hi Finn, hi Turbotimmy, hi Charles. Charles asks, how far away is this nebula? And so just open up a web browser. Wait a second, I'm cheating, I know. But you know what. So what? Open up new window and close the old one. Okay, and we North America Nebula. The North America Nebula was discovered by William Herschel And as I said, it's quite gigantic in the sky. I can show you in a second. Try to figure out how distant it is. Like 1,300 to 3,000 light years. So light from our little backyard travels a second until it hits moon, and it will travel for 4 years, or for some years, to hit the next star. The Milky Way is a few 100,000-ish light years across, so 1,500 light years is straight away in the neighborhood of our galaxy. So it is far away for us humans, but it's quite near in astronomical terms. So for that. No, we can keep that chart. So I Google stuff and then we can talk about that. I don't know whether it's incorporated in Stellarium. Actually, I could give it a go. No, I don't know. Try to. So this is live stacking. What we are doing. So we have a camera attached to my telescope, and the camera takes images after images after images. And we stack those images together, so we layer them on top of each other and then take the average shot of the information. So what we do is we add information, and if you're curious what stacking really means, so from a mathematical standpoint, then make sure to to view my video about that. So I'm a math teacher, so I have a very mathematical approach to stacking. But I think the video really highlights what stacking really is. So right now we are adding information of that target to our image. And I can, where's the right window here? I can try to stretch it a little bit more, yeah. And as we go, the quality will increase. So in the beginning the image was very noisy, and right now it's getting smoother and smoother and smoother with every image we add to that. Okay, thanks Jay. The distances are in Stellarium, so I didn't know that. So Idis asked, what are your favorite eyepieces? Okay, I'm an imaging guy, so I have no expertise on eyepieces. I would choose a 2-inch eyepiece. I would choose an eyepiece with a very convenient light cone, so that you can view through that eyepiece very smoothly. But if anyone in the chat has any expertise on eyepieces, please let us know. I don't know. I go with the standard eyepieces that come with that scope online. I didn't buy any additional eyepieces because I only attach cameras to that scope and nearly never view through that scope visually. So, okay. Osama asks in the chat, is this the whole nebula or just a part? And I will just click back on Stellarium. And here in Stellarium you get an idea of the size of the nebula. So even that is not the entire nebula. So this is what you see right now in Stellarium, virtually, is the core region of the North American Nebula. And the red box here represents our current field of view. So we see this blackish rectangular area. I think it looks like the snout of a dog, I don't know. And if we come back to our program, and then I need to stretch it a little bit different so that you can recognize it. So this is the rectangular area within our live view. So once again, I switch to Stellarium. Okay, and because my scope has a focal length of 750 millimeter, we can't see the entirety of that nebula. So most of the deep sky objects, especially the nebula, are incredibly huge on the night sky. So several times the diameter of the full moon. This is, I think, at least 5 times the diameter of the moon, at least. And this is what we see as like 2 times the diameter of the moon, our field of view. So it's huge. You don't need a telescope to zoom in on stuff. You need a telescope to collect light. And this is the trick. And in many cases, especially for deep sky imaging, having a long focal length doesn't actually help a lot. So in our case, it would be great to use a reducer, but we're lazy these days, so I just go with this focal length and don't care. So we just can look at a small portion of this this nebula. Okay. Yeah, 30–40%. That depends, Charles, on what you count as part of the North American Nebula. Something like that. So, okay. I try to reset the higher the contrast a bit. I can stretch over there. So what I do there is I stretch the data a bit. So I set the white point and the black point and actually like shrink the space where the data is contained to what we need to see, because my camera sensor is very sensitive, and what we would see with the naked eye would be mainly blackness, but there's a little bit of data hidden in certain regions within the spectrum we can collect, and we crop down to that area to make those parts better visible to our eyes. This is what I do when I say I try to stretch out the data a bit from our camera. Okay, so this is neighborhood. This is neighborhood within our galaxy. So solar system, we escaped this solar system, we stepped into the void, and we are looking at nearby nebulosity. And for example, the North American Nebula being illuminated by the bright hot stars within, but also generating new bright hot stars, because this nebula will collapse in certain regions where gravity is stronger, and this leads to form regions where new stars are formed. Because all that gas collapses and gets heated up and heated up and heated up, and at some point fusion kicks in and a new star is born. And this star itself will then illuminate this nebulosity, and we can see that. I think it's pretty damn amazing. Okay. Okay, Jay asked me what Coma correctors are. Yeah, so I did a video about that, so make sure to watch that. And in a nutshell, no optics is perfect, and we need to correct those optics to get pinpoint stars to the edges. So in the corners of my images, the stars would be very oval and distorted, like that, if I would not use a Coma corrector for this specific telescope. And yeah, it comes down to that parabolic mirrors do capture all the light perfectly in one focal point if the light beams do come from the center of the image, and they do not match those focal points if the light beams have a large angle, so if the light comes from the corner of an image. And you can correct for that by just like pre-bending the light in such a way that after getting reflected by my primary mirror in the wrong way, it gets focused in one focal point perfectly. So it includes an arrow that gets cancelled out by the other arrow, and so gets me a good image. And like from for all telescopes, you need some sort of correction lens, because no lens optic is perfect in all areas. So that is true for glass lens telescopes, and is also true for mirror telescopes, just in different ways. So just make sure to watch my video about the science behind telescope mirrors. It's quite an interesting field, but we can't cover it in great detail here. I hope that helped a bit, Jay. And yes, I do use a Coma corrector, though a rather cheap one. But nevertheless, it works. Okay. So, okay, you folks. Charles from Portugal, good night. Yeah, good night. You folks wanted to see another object. That means that I stop the exposures. Okay. And then stop that. And then I will shift all images in a new folder, and we start from new. This was North America. And what I will do after this live session, I promise, that works actually quite well. I will try to get the best out of those images we live stacked in this night, and then upload them on my social media platforms. So we got 14 minutes of the North American Nebula. This is not a lot, but hey, come on, it's a live session. Osama asks, are you affected by much light pollution in your area? Does it have a big effect on what details you can see in these? So yeah, light pollution is a big factor. So I'm imaging from bottle 5 to bottle 6 sky, depending on the conditions, I think. Light pollution is a big factor. So right now I'm using a very modest light pollution filter to cancel out some of the street lights here in the area, but it can't do a lot. And so, for example, the North American Nebula right now you see it's quite like washed out. So there is a little bit of contrast there. I'm proud of our image. It's okay, but the darker the sky is, the less background illumination you have, and the darker your sky, the higher the contrast between the background and your target. So this wishy-washy in my image would get, with the same exposure time, would get significantly higher contrast when imaging from, like, say, a bottle to sky. And this makes a huge difference. So I would need to take like 8 hours, 10 hours from this target, not only 14 minutes from my bottle 6 sky. And I would need somewhat about like an hour to achieve the same clarity and contrast from bottle 1 sky, say. Okay, so it really makes a difference. But, Osama, you can use filters to counteract that. So normally I'd use a very narrow filter, narrowband image filter, to only pick out those hydrogen alpha lines and delete everything else, and hence like simulating a dark sky by only picking my target frequencies. And that works really well, but you can't image every target with a narrowband image. For example, Planetary Nebula shine in very different colors, or galaxies are broadband targets shining in like nearly every color of the spectrum. And if you then use a narrowband image, you only cut out one frequency and lose every other information, so you can't do that. But for those targets, like emission nebula here, like the North American Nebula, it's perfect to use a narrowband image. But we want to move on to other targets, so I didn't include that in my setup this night. I hope this answers your question, Osama. Christian says, mind-blowing to think about that we are one scattered space as atoms. Yeah, someone maybe is watching us right now through their telescopes like 100,000 light years from Earth. That would be super cool. Here, Charles says, the gas cloud on the left makes me want to hop in a Destiny spaceship from Stargate Universe and check it out. Yeah, that would be amazing. but we have other things to do as well. So we slew over. To another target within our solar system. You wanted to see Planetary Nebula, and there we go. I need to check our exposure time. That's fine. I need to realign the scope to the target. Wait a second. So I'm taking a test exposure right now of the Dumbbell Nebula. I think we pretty much nailed it. And then I plate solve that image. Just to make sure that we really hit the target spot on. This is quite a convenient thing to do. So then the computer runs through all the stars and just tells my telescope that my telescope is off by like a tiny margin. Not much. Actually not much. Okay, I clear my folder. I start the exposures, and then I'd say we wait for our first image to arrive. And up until then, I tell you something about the second type of targets we're imaging right now. But first of all, I look into the chat room if something is going on here. What the heck? We got a spammer. Nutzer aus diesem Kanal. Okay, we got a spammer. Okay, Osama has a 150 Dobsonian. That's a great first telescope, so have a lot of fun with that. And we go to Deep Sky Stacker. And view our first. Oh, look at that. Okay, that's quite cool. Okay, what is that? This is a planetary nebula. And so the name is misleading. Planetary nebula means not that there's a planet, obviously, but this is the remnant of a dying star or an aging star. In this case, I think it's a dying star. Dumbbell Nebula, I give it a go at Wikipedia because Dumbbell Nebula. I wonder on the distance. You said I can view the distance within Stellarium. I don't know. Phase, parallax, shift. Oh, whatsoever. I just go to Wikipedia. So. So the distance to us is again within our galaxy. So 1,360 light years distance in astronomy is a vague thing, something like that. So maybe we got a parallax measuring from that. So that would be better in precision whatsoever. So what you see here is the remnants of a dying star. So when stars age, they undergo very complex circles of inner pressure and gravity counteracting the inner pressure and points of stability. And so normally when a star grows, the inner pressure increases and blows the star bigger and bigger and bigger and bigger. So then maybe go from a star like ours to a red giant and a red supergiant. And so in some points, like the inner pressure drops, gravity kicks in, it collapses, then it gets heated up, and then the inner pressure like explodes outer layers of the sun or the star into the voidness of the space. And so this is what we can see right here. I try to increase the contrast a bit. Maybe something like that. Something like that, yeah, great. And this is what you can see. So it is right there. This is the central star. You can actually see it in the image. And the outer shell got exploded away. And normally you couldn't see that because it's very dark. It's just gas moving around. But there is gas in the interstellar medium. And now the shock wave of this explosion hits that gas in the interstellar medium, and both gases are getting ionized and hence emitting very specific wavelength again by giving up their like atomic fingerprint or molecular fingerprint, if you will. And we can image that from our backyard. And this is pretty cool, I think. So this is the explosion wave. And if you waited long enough and took another picture, like in 100 years, you actually could see it moving and expanding. And there are different layers in this exposure, in this explosion. But we would need like 5 hours, 6 hours of exposure time, and not only 4 minutes to reveal those different layers. Okay, back to the live stream. Like that, okay. Okay, South of England. Darko asks, how much is the primary mirror and the focal length? So I'm imaging at 15 centimeters of primary mirror and a focal length of 750 millimeter. So it's an intermediate scope. So like 15 centimeters or 6 inches of primary mirror is actually quite small for imaging telescopes. So an 8-inch would do a better job, obviously, but a 6-inch is doing just okay for me. Yeah, and 750 millimeter focal length is somewhat an intermediate focal length. For some targets it's too small or too short, and for some targets it's too long. Like the North American Nebula, we would need somewhat like 400 or 350 millimeter focal length to really capture the whole. But what we can do is we can mosaic us through the target. It's a bit of a pain, but it works. And like this, we can just crop the image, but then we lose resolution, of course. If that answers your question, Darko, sorry. So, okay. Again, while we talk, the quality of the image does. Oh no, this is totally overstretched. Does increase. Because of stacking, yeah. So we add information and we add information, and you see like we are now at 6 minutes of adding data to this target, and in astrophotography this is nothing, yeah. So you always calculate in hours of exposure time, if not days, in sometimes some rare cases, but normally hours. Like say, spend like 4 hours on a target. That's solid. Like 8 hours on a target to get really smooth edges, because as you increase the exposure time, the gradient within your image the gradients are getting smoother, and you can stretch the data much harder to reveal even fainter structures, because you added information, and all the added information can be made visible afterwards in post-processing. So, yeah. Okay, Dave. Hi, Dave. What mount are you using? I'm using a Skywatcher EQ6R Pro mount. This is a solid amateur mount. I mean, it's not a beginner mount. It costs like 1.5K-ish if you get any these days. Hard to come by. And it's very precise, and you can slew. The pointing accuracy is really good, and if I plate solved my my mount and synced it, and I re-slew to another target, even on the other side of the sky, it like pinpoints that target. It's really nice, very convenient to use. And anyway, the quality of guiding is really good. So it's a heavy mount, though. I really need to carry a lot with this mount. So I never disassemble the mount. I carry the mount and the telescope in one piece to my telescope shed and out when imaging again, so I don't need to disassemble or reassemble everything every night. That would be a pain in the ass. And yeah, but it's a solid mount I really like, and I would recommend this mount. That was the question of Dave. And Charles gives a fun fact. The explosion of those guns are expanding at 31 kilometers a second. Yeah, this is interstellar speed, so that's incredible. Just for comparison, so like if you're circling the Earth, like the International Space Station or any satellite, you're going at 9-ish kilometers per second. Okay, 9 kilometers every second. This is quite fast. So you circle the entire Earth in like 90 minutes. That's insane, yeah. But then this is like solar speeds. Then you have the fastest probes we send are like a few 10-ish kilometers per second, like 10, 20, 30 kilometers per second. I think I don't know the exact speed of the Voyager probes. Or New Horizon was, I think, the fastest probe we sent there with around 30 kilometers per second. And then you see these are the speeds to escape the gravitational well of a star. So the gravitational pull would pull you back, so you need like multiple times of 10-ish kilometers to escape a star. And those gases are quite fast. And then you have intergalactical speeds, like the speeds of galaxies relative to each other are like 100-ish kilometers per second. So these are the different like grades of speed in the space. Thanks for all that insight. Except that our sun will create Planetary Nebula too. Yeah, but this is a far future, and not every star produces those. So many just shrink and dim and get to different phases like brown dwarfs, and then they just cool off. Others explode in supernova. Others implode to black holes. So it depends on the size and the mixture of the gases within a star, what path it will take. So our sun will grow and will eat up, I think, Mercury, maybe Venus, heat up Earth way beyond anything that could host life, and I think then die. I don't know how. It's sad. Okay, F5. Yeah, Darko. I image at F5. Okay, Turbo Timmy. This is Deep Sky Stacker. So I highly recommend a set of software for anyone getting in touch with astro and astro imaging, astrophotography and stuff. So you really need Stellarium. This is the basis. You need to know the sky, you need to know where you are, and Stellarium will get you there. Stellarium is free, Stellarium is epic. This is Stellarium. You can just enter all your camera specification on the upper right corner. Like your camera, your telescope, everything, enter it there, and it will give you this convenient red rectangle, and this is your field of view, so you can actually like preview what you're gonna see. And then you can enter time, date, your current location, your backyard, everything, and just slew around the night sky and get to know stuff. And this is really important. And I'm using Deep Sky Stacker for stacking my exposures. So as I said, my mount is solid. I do the guide if I do proper imaging. Not right now. But you can't like take exposures way over 5 or 10-ish minutes. That's not possible. You would overexpose your sensor, and like instability in tracking would knock you off. So you take like say 5-minute exposures. You need like hours of exposure time. So you stack all those exposures on top of each other and take the average or anything else. But you add the information, that's the point. And I use Deep Sky Stacker, and this is free as well. And for beginners, it's the perfect place to start. If you image the night sky through, say, a DSLR and a camera lens, that's totally fine. And then just take RAW modus and take 20, 30, 50 exposures of this part of the sky you want to image. And if you can only expose like for 1 second, that's just fine. Then do it. And add those seconds onto each other using Deep Sky Stacker. And Deep Sky Stacker is just a fantastic piece of software, especially for beginners. And I use Deep Sky Stacker Live, and this is a modus where you can say, there's a folder, I will drop images into this folder as they are being captured, and then ask the software to live stack those. So the image is now quite smooth actually, and it was very noisy in the beginning. If you increase the data, you get smoother images, and this is what we are doing right now. So we start with a very noisy image, and then we end with a very smooth image. Like now we have like 13 minutes, and I think we're gonna go for like 15 minutes on each target and talk about the target and stuff. And yeah, you can see much more details now compared to the beginning of this target. Okay, are there good, cheap, optimized mounts for starting? Asked Christian. I would recommend the Skywatcher EQ3 Pro mount. It's not really cheap, but it's solid. I own that mount. You can't put a very heavy telescope onto it, but a small telescope will certainly do. It's better for beginners. Just take a small telescope, take something like 400-ish millimeter focal length. That's totally fine. And you can guide with that telescope. You can do auto guiding with your computer. And you can connect it to the PC in the same manner as I do it right now with my EQ6R Pro. So it's a full-grown solid mount. It's just not as capable as the EQ6R Pro, but it's really cool. I love the EQ3. I would highly recommend it. If any of you have another opinion on that, please just share it in the live chat. Dave has the NEQ6 and struggles to polar align at his latitude. Dave, you need to elaborate on that. What do you mean with you struggle to polar align? What do you do to polar align? So, just as a recap or in a nutshell, polar alignment needs to align the rotational axis of your telescope with the rotational axis of Earth. And so you need not to slew the telescope to a certain position, but to move the actual mount to a certain position. And you have knobs for left, right, and knobs for up, down. And so you can move the mount with the telescope on top to a certain position where the rotational axis of the telescope and the rotational axis of Earth do match. I did a theoretical video on that, not a practical though. You can watch that. And oh boy. Boy, I got a spammer. That sucks. I mean, is it a compliment that Why are spamming bots on my channel? I can't. Yeah, and there are different ways to polar line, to come back to the topic, Dave. And I use SharpCap. This is the third piece of software I highly recommend buying. Actually, you need the pro version for, I don't know, like 15 bucks a year stuff, or 10 bucks. And it's perfect. You can polar line with SharpCap using your guide scope or your main imaging camera within minutes. It's perfect. Charles uses Sequencer to understand the basics. Yeah, Deep Sky Stacker next. Deep Sky Stacker is more of a basic beginner tool, so you can use any stacking tool in fact. So I just use Deep Sky Stacker because it works independently from every other piece of software, and I used it to stack images I took throughout the night just with my DSLR, and it worked just great. I kind of stuck to that software up until now. I don't know. I wanna move on to other software solutions that incorporates all of like guiding, pointing, planning, stacking, first processing, all that into one piece of software. There are software solutions out there, but I haven't covered them yet. Turbo Timmy, can I download DSS Live? Yeah, you just download Deep Sky Stacker, and I think it's included in that, so it's free. I think it's even open source. Dave. The up-down bolts are at the limits in London? Not possible. I don't think so. Really? That would be super, super strange. However, you can tilt the entire mount, like you can re-level your mount with a tripod. So that's not super cool. Everyone tells you that you should level your mount, but I mean, if you can't reach polar alignment any other way, I would recommend just to tilt the the entire tripod by just lowering one leg or extending one leg more. The thing is, you need the alignment of those two axes. That's the most important point. And normally it's best to keep the tripod leveled, but it's necessary to have polar alignment. So just give it a try. Try around. If it works, it works. If not, not. Okay. Darko. Okay. Thanks, Drew, for the thanks. Always appreciate your feedback on those videos. Yeah. Okay, so we did like 50 minutes on this target, and I think we should move on to another target. I just Ring Nebula was one of your suggestions. Okay, or the helix. Ring Nebula is beyond Meridian. We can do it either way, but okay. So the Helix Nebula is not in reach right now. The Ring Nebula is another planetary nebula. Ah, come on, why not? So, okay, stop imaging. Then move all the files to a new folder. We had the Dumbbell Nebula. Like that. Then ask Stellarium. This is Stellarium. This is the Dumbbell Nebula, and ask Stellarium to. Can you see the window in there? Yeah. Current object and slew. So right now my telescope is slewing, and the telescope needs to like flip, do a meridian flip, because if it would continue on this path, the counterweights would be above the telescope. And you never want to do that, so the telescope just flips around and do what is called a meridian flip. If you let your telescope do a meridian flip alone, it's sometimes a bit scary because cables can snag and then pull over the entire telescope, and that actually happened, and you don't want that to happen. But my cable management is actually quite good. So cable management is where do you put all the cables from the camera, the heater, the camera sensor, the guide cam, everything. You need to pack them in such a way that they can't snag. Okay, so Stellarium thinks that we are on target. I'm gonna do a 10-second exposure just to verify that we are on track. So the middle cross section is where Stellarium thinks my telescope is, but slewing arrows will actually add arrows to that internally. So, and then we take a test exposure, and then we let this text exposure be solved by a plate solving software that looks at all the stars in the image and then calculates where it is. And there you see we are just a little bit off. You see that? The orange circle has moved to the to the right hand side of our field of view, so we are off like by a small margin. And I let Stellarium re-slew to the target right there. And then I delete this. And we gonna create a new file and start capturing again. And then this is what you can see in Stellarium. So the ring nebula is very tiny. So this is what it looks in Stellarium. This is not what we're gonna see with our telescope. Wait and see, it's really tiny. You saw that I really needed to zoom in. Okay, wait a second. And there will be our first exposure in a second, just, okay. Okay, in the chat room. Probably aiming to the wrong point. I don't know what you're talking about. Yeah. Drew Little John says, imagine what it was like plate solving without software. So it is called plate solving. Oh, you know what? I need to tweet something in real life. I forgot that. Oh, why did I forget that? No. It is called plate solving. Why is it called plate solving? Because that's quite a funny bit of information. The big, oh, there it is, haha. The big telescopes back in the days, they imaged on glass plates. So they exposed glass plates covered with certain chemicals, and they needed to know where they are. So they used either a focal reducer or another aligned telescope to get big plates of stars, and they collected those plates. Then they did a test exposure like we did, and then they compared their exposure on a glass plate with other glass plates and went through the through the stack of glass plates like and compared until they found the right orientation of stars from their glass plate with the glass plate of the of their stack, and then they knew where they are and where they need to go and stuff like that. So that was really difficult, really hard, and I'm so proud of today's computers that we don't have to do that anymore, and it's super easy to do it our way. Okay. because without we would need to like go from star to star, do star hopping and stuff like that. So, okay. This is the target. It's actually pretty bright. And so I need to re-stretch the image to something like this. So you can actually see some color there. But my telescope has a way too short focal length for this target. So this is the target. It's a planetary nebula. Again, it's within our own Milky Way. Again, it's the outer layer of a dying star, shining in different wavelengths. And sometimes you can just make out the central star there. I don't know. Yeah, maybe. This is the whitish dot in the middle, and this star just blew away its outer layers some time ago. Ring Nebula. The star became a white dwarf. It was discovered by Messier in 1779. The distance is 2,500-ish light years from Earth, something like that. So again, like direct neighborhood. And does it tell anything about the excuse me, the properties? There's no direct information about the diameter. Oh, there. To be expanding for the next, although has been expanding for 240-ish years. So those objects are quite dynamic in astronomical terms. So they do really expand. And if we would image for years and not for minutes, we could see the movement of this gas cloud over there. Okay, back to the live chat. What does automatic go-go navigation means? I'm currently watching the EQ3 mount that you have told me. It can be moved the same way with remote control and through a program. Yeah, that's true. So the EQ3 can be moved around by a hand controller, and you can star align the mount with a hand controller, pointing at different stars and then telling the mount that you saw the stars. And the mount is like, it has an internal map of stars, and you have the real world, and it's like aligning those two maps. This is like what star aligning is in a nutshell. And then you can say, oh, I want to image the Ring Nebula, and if the pointing accuracy is good enough, and if the star aligning was good enough, it will point to the Ring Nebula. Not to be confused with polar alignment, which is the alignment of those two axes, the rotational axis of the telescope and the rotational axis of Earth. And a polar alignment is needed for long exposures. And like you see, like here, either our focus is slightly off or the alignment is slightly off, so we have roundish stars. It doesn't matter for now. But so if your star alignment is good and your pointing accuracy is good, you will find the Ring Nebula. Or you can do this actually the same thing, just through software using EQ-mod. This is the software you need to control your telescope via computer. I will do an entire video about software controlling your mount, but not now. So you need EQ-mount to like simulate a hand controller through a USB cable onto your mount. There's an additional cable for connecting the mount with the computer using EQ-mod. And then it's just USB, plug and play. You open up EQ-mod and you can plate solve and resync the scope and stuff like I do right now. Okay. That's nuts. Charles has respect for pioneer astronomers. Yeah, really, like, I mean, Charles Messier, he did it all visually. Can you imagine that? He sat there night after night after night after night and like, his scope was tiny compared to what's out there nowadays, and he found those objects. He wanted to find comets, and then realized those fuzzy objects in the night sky, they don't move, they can't be comets. So he wrote a list of objects not being comets, not to be confused with comets, and this was the birth hour of the Messier Catalogue, which is very handy for amateur astronomers because these objects are very bright and mostly very cool. And you can see them from our backup because Charles Messier could do so as well. And thanks to him for creating this list. Okay. Thanks, Osama. What do you do for a living? I am a teacher. I'm a science teacher. I'm a physics teacher, and space is just my dear hobby. Yeah, genau. Charles says GoTo means you can enter a target and your telescope will slew there. You don't need to do it like manually. There are manual telescope mounts, and you need to like turn a knob to turn the mount, but GoTo means there are motors there, and you can say point to the ring nebula and it will point to the ring nebula. Very convenient. Okay, you see the quality of the image does increase a bit as we speak. I try to brighten. No, that's too much. Yeah, you can see the central star quite well now. It's not a fizzy blob now. Sometimes it looks like a real star. Yeah, maybe we need to refocus after a while, but I do not guide right now. So guiding means you take a second little telescope on top of your telescope, a telescopeception if you like, with a separate little camera, and let a software take a look at one specific star, or at least a bunch of stars or something like that, multi-star guiding, and then determine whether the tracking of the night sky of your telescope mount is really precise. So if this star stays where it should stay. And if not so, send correction impulses to the mount and corrects for any errors. So, but I don't do that right now because I'm too lazy. And right now we are only doing like 1 minute exposures, and who cares? Yeah, 1 minute exposure is short enough for my mount to normally do without tracking, without guiding, excuse me. I think we have focus issues on the stars, so we might, between now and the next target, retry the focus. Okay, so these are the planetary nebulas. Okay, you wanted to see a comet. Okay, so the comet is not in view right now. Back to the chat. Thanks, Dino. Thank you very much. Drew asked me if physics is the really true science, and as a physics teacher, I need to say yes. Wanda wants to see the Andromeda galaxy. And DOS463, so is this auto-guiding sense correction while taking the images? Yes, so you need a second camera. Look for the star, for one auto-guiding star, and then if there appears any movement within this star, the software automatically sends correction to the mount to keep that star center. And if everything works good, you are in sub-pixel accuracy for your imaging camera, so that the stars in your imaging camera don't move more than a pixel during your imaging session, or during your image capturing. And this is called guiding. And back in the time, you needed to do that manually. So you looked through a second scope and like fiddled with knobs to keep that star centered, but we have software solutions right now. And this is quite convenient these days. I try to find the correct location of the comet, because that would be a cool thing to do, imaging a comet. Solar system editor. I try to add what do I have to do? Plugins, solar system editor, configure. Import from file. No, I don't want to import from file. What is happening? Solar system. Import new file. From Gideon. Okay, why not? I don't know, Gideon. I try to update Stellarium to get the new Comet, but I think it doesn't work right now. 270C. It's not included here. Okay, there are all the comets available. C217. So maybe we can update Stellarium. 17, 19, 18, 17. Pan-star. Add objects. Okay, maybe it works. Maybe not, I don't know. And I can see some 216 pan-stars. But I think, yeah, we are out of luck. It's still not in the field of... Okay. Okay. Oh wow, the chat exploded. What's going on here? Okay, it's about physics, theoretical physics. Okay, there's another question. Osama asked, how do the stacked images compare to what you would see through the telescope's eyepiece? So, through a telescope eyepiece, you only see grayish, fuzzy stuff, because your eyes can't see colors when it's dark, so you can only see black and white. That's down to your retina, and you can't see very sharp with your black and white vision, and stuff is very faint. So, for example, the Milky Way, the Andromeda galaxy, you can make out structures when imaging, but you can just barely make out structures. You see the central blob and then a gray, faint, hazy surrounding, but not the real structure and all the colors. They are not as vibrant as here. So this is a very, very bright object. You could see this ring nebula with an eyepiece, and you can actually probably can make out some colors because it's such a bright object. But normally it's black and white and fuzzy-ish, but you see the photons with your own eyes. That's something cool as well. Yeah, gray smudge is that. No much detail, colors only through bigger telescopes. Okay. Mitza and Alcor. Charles wants me to look at some stars. Okay. I normally don't image stars. What the heck? Why not? It's and after that, okay, stop. I need to put all files in a new folder. That was Ring Nebula, so that I can stack them afterwards. Don't delete them accidentally. Then stay stop. Then go to the target, current object slew. So, as a background story, Charles wants me to go to a star. A binary, is it a binary star system, Charles? So some stars you can see with the naked eye are not actually one star, but actually two stars. And if you look through them through a telescope, you can resolve the stars. And we're gonna shoot a test exposure. And done with the Ring Nebula. Turned out really well. I'm proud of us. And now we then we take a test exposure and plate sulfate. Okay, here's Stellarium. These are the stars we are looking at, and you see our telescope is slightly off. That won't concern us much, but we're just gonna take a few test exposures here, but we're not gonna overdo things. Oh, what we can do actually, because why not, we can focus because we really need to do that. Wait a second. ATP. Okay, excuse me, where am I? There. Ha, hi. So this is ATP, my capturing software, and we're gonna focus. I'm using a Bahtinov mask to focus, and I'm gonna show you how it looks. It's quite cool, and we can use those stars anyway. We wait for the first image to appear. Okay. Okay, astrophotography, Osama, is really expensive. That's true. But if you have a DSLR already, then you can take a DSLR. And you can take images through your eyepiece using your smartphone. That's cool as well. Dino is there. He wants... Yeah, we can visit the Andromeda galaxy as well. And yes, 127 mm is nearly not enough to see any structure within the galaxy. Galaxies are just super faint. So, okay, we have our stars over there. They actually look pretty good, but they are bright and we need bright stars. And what I'm going to do now is I'm going to use a Bahtinov mask. That is a geometrically formed mask in front of my telescope that will distort the way of the light rays in such a way that it will create certain patterns. You will see what I mean. And we need to create one certain pattern in order for this to work, and then we are focused. Okay. We need to stop. We need a live view. And then I'm going to my telescope. I'm back in a second. I just want to show you something. Okay, now what you see right now there is this pattern I talked about. So I put on the Bahtinov mask and we're gonna take a test exposure. Wait a second, and then you see what I mean. We're gonna quit live view and shoot a short text exposure, 10 seconds. Clip on my microphone back. Okay. Done. Okay, the focus is not bad. Okay. So this is the pattern you're looking for. There are two spikes and a central spike. And those spikes are created by this mask in front of our telescope. And by moving the focus, you move the central spike up and down. And you want it right bang in the middle. And we actually are right in the middle. So the distorted stars from our ring nebula image, they come from bad guiding. Not bad guiding, bad tracking because of no guiding. And that's okay for us right now. But these are diffraction spikes. And yeah. Okay, Charles says Messier is a binary star and looks like a bright one star right now. And Christian, yes, that was live view. And now we took a test exposure to reveal this Bahtinov pattern of the star. I will remove the Bahtinov mask now because we know focus is right on track. Wait a second. Then we can take another short test exposure. Oh no, spamming bot. That sucks. Okay. Okay, we're gonna take another shorter exposure, like 2 seconds, and we see whether we can resolve the different stars. Yeah, right there. Okay, even shorter, 1 second maybe. Cool, look at that. We resolved the binary system. Can even go for a little shorter there. Chuk chuk. I don't think we can. Yeah, now you can really see those, and this star is actually 2 stars. And actually, you're telling us it's 4 stars. Yeah, I can't zoom in anymore. And the stars are so bright that we can. Look at that. Use a 50th of a second. A 100th of a second. No, they're too dim. 60th of a second. Okay, wait a second. I'm gonna increase that just a little bit. Yeah, it looks like you can definitely make out different stars. Wait a second. Desktop. Where's the snapshot? Over there. Show the image. Increase image size. So here you can see that there is some more structure behind that. So the 2 stars are actually more than just 2 stars. But my telescope is not capable enough of really increasing the resolution. So there's a limit on what you can resolve with each telescope. So these might be 4 stars. We can only really make out like 2 stars, but they are so. There seems to be some more structure within that. So, Charles, thanks for that. Cool, cool, cool. Yeah, no, thank you for the background information about this. I didn't know that. It's super cool. This is why I love those live sessions so much. Cool, cool, cool. Okay, but enough of those stars. We want to image something else. For example, I think now it's time to go past our own Milky Way and step into the void and image some other galaxies. I think that would be super cool. So we slew over, and oh, I don't. There to the Whirlpool galaxy. This is an edge-on galaxy. And again, I need to get rid of all the files on the folder. Tell it star. And tell APT to start capturing now. Our test exposure to verify that we're on track. Something like that. And we're gonna see where we are. It's super confusing, all the different windows. Okay. Well, I mentioned Andromeda. Yeah, I mentioned Andromeda. We're gonna see Andromeda as well, but right now we're gonna see something else. Wait a second. Okay, so you can't see much in this image. I think there's the galaxy we're gonna see. We're gonna solve this image and see if we're way off. So the image calculation software is extracting the sources, finding stars, parsing the result. Yeah, we're just off by a slightly by a small margin. And we tell Stellarium to recenter, and we say APT start. Okay, and we say Deep Sky Stacker, create a new file, and do live stacking. And then I can come to the chat and see if there's anything new there, and then we head over to Wikipedia to enter Whirlpool galaxy. Like that. So this galaxy is not thousands of light years away, not 10,000 of light years away, it's not 100,000 light years away. That would be all within our own Milky Way, so within our own galaxy. But this galaxy here is 31 million light years away, and here comes the first stacking image. Here comes our live view on this distant galaxy over there, and it's we zoomed, excuse me. And I need to stretch the data so that we can see anything. Increase contrast. Fiddle around with the settings a bit more. No, the data is somewhere here. Oh. Yeah, we just need more data. So this smudge here is a distant galaxy. You can see the bright core of this galaxy, and you can see some of the rings around this galaxy, the arms of this spiral galaxy. Because it is a spiral galaxy, just like our own Milky Way galaxy. It doesn't have a central bar, but a central bulge. And within that a very bright core. In the center of this galaxy is a supermassive black hole, concentrating like millions of sun masses. And you can see another white core underneath this galaxy. And this is actually a second galaxy. And those galaxies do interact with each other gravitationally. And the smaller, lower galaxy is it's gonna be eaten by the bigger galaxy. So there are tidal forces pulling on both galaxies, distorting the structure of the galaxies, or distorting those spiral arms of both galaxies. The lower one is getting ripped apart. The mass, the stars, the gas is ripped out of this galaxy over millions and millions of years. And the bigger galaxy will swallow the smaller galaxy, as galaxies do. And Turbo Timmy says, can you try 106? Another galaxy. Yeah, we just want to capture some data on this, and no, 106 is behind my roof, unfortunately. And I try to... I try to fiddle around with the settings so that you can see. See the galaxy a bit better. It's quite hard. Galaxies are faint shit. Excuse me. So if I overstretch the data, I think now you can start to see the structure of this galaxy a little bit. So we have this lower companion galaxy down there, and we have this visible spiral structure of the main galaxy. It's quite beautiful though. I like that. Yeah, what a shame, Turbo. Sorry. There are constraints. The house is not debatable. And the target is beyond this house. Behind this house. Please have a look at my question just above my last above the last crappy spam chat. Okay, sorry. So, Durs463. I'm extending from wildlife to astrophotography. I just brought a mount, the Exos 2 PMC8 for use with my full-frame DSLR and a 150 to 600 millimeter lens f4.5 to f6. I don't know this mount. I need to Google it. I can't know every mount. Excuse me. Okay, this telescope mount goes up to 13 kilograms, and I think it's go to Exos 2 PMC. Yeah, this is a motorized go-to mount, and if you are using your full-frame DSLR and your lens, then you will be able to take images of deep sky objects, of course. So lenses do have problems with chromatic aberrations and distortions of the corner stars, but just don't bother with that. Especially if you're a beginner, just ignore that and crop the images to the central region. Your mount will be, I think, more than capable of handling your DSLR and the camera lens. So that would be like something of an overkill. Maybe you don't even need some counterweights. Just try it. But yeah, the saying goes like this: use what you have. And if you have a DSLR and if you have a camera lens, then just use it. Use it with this mount, and I think this mount will be useful for even a small telescope or mid-range telescope. But your camera can be attached to that mount as well, and you can use your telescope, your camera with a camera lens, and that should be fine. I mean, 600 millimeter focal length is something like my telescope. You just need to expose longer because you don't have the same aperture, but then do so. Not again. So these spamming bots are everywhere. What's happening? Okay, that's really impressive. That's really impressive details, says Dave. How long was this exposure? So right now our exposure time is like 6 minutes, but we are trailing, stars are trailing. It's not so good, whatever. 6 minutes, and yeah, it's super reddish. But what can you do? I'm stacking 1 minute sub-exposures to answer the question of Dave. A total of 8 exposures right now. Okay, the Crescent Nebula. Okay. Dino asks, how do you interact with the telescope? Do you have a go-to system connected via computer? Yeah, okay. Normally your go-to mounts have a hand controller, and you can align the internal map of the telescope with the real world called star aligning, and then you can punch the target into the hand controller and just go to your new target, like for example the Whirlpool galaxy, and the scope will use its motors to slew to this position with higher or less higher precision depending on your mount. And I just got rid of my hand controller and connected the mount directly to the computer, and the computer acts as a hand controller, and you use software, for example Stellarium, which is a fantastic Stellarium piece of software, to tell my mount where we slew. And I can show you in a second, when we slew to another target, how this works. It's very easy. It's plug and play. You click it, you say slew to this target, and depending on the slewing accuracy of your telescope, it will go there. And then I do plate solving. That means taking a test exposure, letting a software determine where I really are, and then resync the position, the real position, to the scope, and then I'm back in the game. Yeah, Darko, I blocked him, the spamming bot, for the like 20th time in a row. It keeps up appearing, I don't know. What's up? Whatsoever. Yeah, that's the way we go here. This is the galaxy, and yeah, we say stop exposing. And I can show you how this works right now. So the slewing and stuff. So we are here in Stellarium. We want to visit the Andromeda galaxy, because why not? But to be warned, we see right now we can't fit the Andromeda galaxy in one frame with our camera. This is the power of Stellarium. Okay. We can see our field of view because we entered all the details, and we can't fit it in there. It just doesn't work. So whatsoever. We say center of the screen and slew there. And our telescope is slew there. And it'll take a while because it has to do a Meridian flip again. That's just the way it is. Oh, and afterwards we can jump back into our own Milky Way. Now I messed up the order whatsoever. And visit a globular cluster, because globular clusters are so beautiful. We need to do that before ending the night. Okay, are starlings any problem? I don't think so. Not for me, at least. I mean, for professional astronomers, maybe yes. Not for me. I erase those subs where I have starling satellites, and even if I want to keep that subs, I use a technique called Sigma clipping to get rid of the trails. So for me, it just doesn't matter whether there are starling satellites in the night sky or not. At least as long as I do get more time on the image as I get on starling satellites. Okay, solved. Where are we? We're EQ is there. You want to be there. Okay. And I'm gonna shoot a 15-second exposure just to give you a feeling of what a galaxy looks like through an eyepiece. So this would be like, if you would use binoculars, you could see something like this, the inner core of the galaxy, okay? Not more. If you use a small telescope, you could see something like this. This was a 15-second exposure. and we're gonna shoot a 30-second exposure, just because we can. And I think we're gonna see something in the order of what you could see through a mid-range telescope. Let's see what 15 seconds do, 30 seconds do. M16. Yeah, Dino, so this is a powerful connection, so always connect your scope to the PC. It's super helpful. Okay, so I think if I look through my eyepiece, I maybe see something like that. Maybe, I don't know. And now we go all in and take a minute-long exposure. Wait a second. Again, all the files in a new folder. This is Whirlpool. Before, to empty that folder, reset that, tell them to restack, and let APT start a new plan and just go all in. Yeah, now you start to see the two companion galaxies of the Andromeda galaxy on the bottom half of the image, and on the top right hand corner, a little fuzzy fuzz. No colors, no structures up until now whatsoever. Okay, and we're in Deep Sky Stacker again and waiting for the first image to arrive. Darko really wanted to see Andromeda. And so it shall be. The Eagle Nebula is probably... No, the Eagle Nebula is behind a tree right now. Okay, we're gonna stretch that data. Stretch it, stretch it. Okay, and now I stretch the data a bit and you can see the inner core of the Andromeda galaxy. You can see the two companion galaxies. You can see dust lanes going around the Andromeda galaxy. You can sort of differentiate between the background and the nebulosity of the Andromeda galaxy. Kind of, not really. You need a lot more exposure time for that. And dark skies, and I don't really have really dark skies, so the background glow is quite annoying here. But this is the Andromeda galaxy, and this is what you can always see through a camera and not through an eyepiece. I mean, with really powerful telescopes you could see this through an eyepiece, but not with our. Why is your 30-second exposure of M31 not red like the others? So, this is actually background. Right now I stretch the data, so you see the background much more vibrant. But anyway, if you do a short exposure, then it's black. And if you do a long exposure, the background glow gets through and you get your target, but as well you get the background. So, and all the stray light there is mostly reddish light. And right now I stretch the image data to reveal the most contrast-rich and detail-rich segments of the image, just to enhance the visibility. And this is why I unfortunately also increased the background noise as well. So this is why there's this reddish glow on this as well. And the other ones were not stretched. The 30-second exposure was not stretched, so this is why you mainly saw the blackish background. But I wanted to give you an impression on what's possible visually. Try to make it look cool, but we need to do post-processing on that. And we only have like 3 minutes. That's not much. so this is what we get through a telescope looking live at the Andromeda galaxy, just because Darko asked me to. And I think you were on the choosing all night long, and I think I'm gonna choose the last. Target of the night. If we are done with the Andromeda galaxy. And again, the Andromeda galaxy, so this is, it's actually not that far away. Like, astronomically speaking, it is another galaxy, like our own galaxy. It's even bigger. It is our, like, big sister galaxy. It's relatively close by. It's in the same group of galaxies like we are. And it's actually heading towards us. And I think Darko was relating to that fact when he said he scheduled his dating with the Andromeda galaxies to, excuse me, a few billion years. This is actually what's gonna happen. We are colliding with this galaxy. So this galaxy is moving towards us with something like 100 kilometers a second, and we are gonna collide and building up a huge, messy new galaxy in the future to come. But please be assured, nothing harmful will happen to us, because, like, as cool galaxies look, they are mostly nothing, like emptiness and void. And stars are relatively sparse within galaxies. And so if two galaxies collide, it's mainly the gravitational interactions of all the stars that lets them merge, but you never have like star-to-star collision or planet-to-planet collision. That just doesn't happen. So we will be fine if we are around like 4, 5, 6 billion years from now on. Who knows? Trooper Timmy asks, are you using any filters? Yes, I'm using a modest light pollution filter because I want to capture broadband targets, and so I can't use a narrowband image filter. Charles is appreciating those live sessions. Yes, I do appreciate those live sessions as well. I really love them. It's so cool. I mean, I could sit here in the dark alone, but I could as well like invite 20, 30 cool people into my garden, and that is like from all over the place, like from US, from all cool countries, and we can just chit chat about astronomy and stuff like that, and talk. And this is so cool. I really, really, really like you. Yeah. Yeah, see you next time, Charles. Bye-bye. 110 kilometers per second, says Alfred. Yeah, that is... Oh, I have to block the chat bot. Yeah, thank you, Alfred. 110 kilometers per second. That is actually quite fast, so... and we're gonna collide in a few billion years from now on. Okay, you know what? We let APT stop this image. We're gonna select those images and move them to no folder, Andromeda. and we're gonna move to our last target, which is Windows over there, which is the Great Star Cluster in Hercules. These are quite interesting targets, those star clusters. Though they're clusters of stars, hence the name, yeah, like 100,000 stars, 200,000 stars, something like that. And they're within the main influence of our galaxy, so they're considered to be part of our galaxy. Maybe they are. They are orbiting our galaxies at different orbits, halo orbits, that do not match with our disk of our galaxy. So, and they are thought to be like captured galaxies or the cores of captured galaxies, but we are not sure. It's a matter of scientific debate on what the actual origin of those star clusters are. But having said that, they are quite beautiful. And we're gonna shoot a test exposure of this target just to make sure we are on track. And then plate solve that image. But we are relatively close, look at that. So this is what I meant with I love my EQ6R Pro telescope mount. We slew right, we did a Meridian flip and slew over the entire night sky. And we're like dead on. This is cool. Actually, pretty cool. The halos do touch? Cool. Wow, 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 wow. Good night, good night, good night, good night, good night. Durs463 asked me where I'm situated in Germany. I'm situated in mid-Germany in the rough surrounding of Hanover. So it's the main capital of Lower Saxony. Would you look at my pictures and give your opinion? Okay, Alfred, and any other visitors in the chat room, if you take pictures of the night sky, please share them on social media like Twitter, and then link me, because I'd like to see them. You can contact me via Instagram or Twitter, or via my mail address. I link this on all those informations on my YouTube channel. And yeah, just get in touch with me. I look at every astronomical image. I love astronomy, so, and I would love to give my opinion on those images. Absolutely, yes. Okay, so we say new image session. And yeah, we want to image this little friend here. This is the core region of the Hercules cluster, and this is just a 15-second exposure, I think, and so you can see all those stars. They're gravitationally bound to each other, so forming a roundish, blobbish conglomerate of stars, and the colors and the structure within those globular clusters. It's just super cool. I really love them. Globs are super cool. Some say one glob is like another. Excuse me. I highly disagree. Because look at that. I mean, this is beautiful, isn't it? It's so cool. What is Deep Sky Stacker saying? Oh, you have a satellite trail there. Look at that. That looks actually pretty cool. Sweet. I try to stretch the data. I think that the preview here in ATP looks better. I don't know why. This is cool. We just stick with that. So this is the full frame, and the glob is here. And M13 is cool. M13 has a like Mercedes-Benz stylish cross in the middle, and now you see it's like it's blurry. This is because the tracking was not good, and so the stars do trail, and then the image gets blurry. That's not cool. And yeah, but what did I say? You have this Mercedes-Benz like-ish triangle in the lower part of the cluster. This is like it's a distinction signature of M13, the Hercules cluster, and all those vibrant stars flipping and buzzing around each other in this gravitational wealth. It's super cool. It's such a cool system. Yeah, those for astrophotography can be sometimes a lonely thing to do, because even if I could meet with people, both would need time on their hand. We need to take weather into consideration and all this stuff. So normally it's like, oh, it's clear, I go outside like now, and then to try to find people that have the time to meet you right now. it's quite difficult. So this is why I love these live sessions so much. Darko, yes, yeah, the remnants of earlier collisions most definitely formed our Milky Way. That said, the formation of galaxies is a matter of ongoing debate in the science community. Like, ask Becky, Dr. Becky Smethurst. She has a YouTube channel. She's just the best. She's an astrophysicist, and she explains astro stuff in such a great way. She's just the best, and she does research about supermassive black holes and the evolutionary process that forms galaxies, very loosely speaking. So it's very complex, but super cool and very, very interesting, and her videos are just cool. I don't have a all-sky cam, and I don't think I'm interested right now in building something like that. I want to build a fully automated astronomy shed where I just can operate my telescope from anywhere in the world. That would be super cool. Just turn it on remote, like a remote telescope, just from my home. That would be great. With roll-off roof and everything. This is a long-time goal for me. Okay, folks. So we imaged different things. We imaged nebula. We imaged planetary nebula. We imaged globular cluster. We imaged double star systems. We imaged other galaxies. We imaged our neighbor galaxy. We imaged a galaxy eating another galaxy. We did live stacking in Deep Sky Stacker, which was really fun to do. This is the image we get out of live stacking right now. This looks very cool, though a bit reddish whatsoever. We have like 5 minutes on this target. And it's 1 AM in the morning here, and I think I'm gonna say good night to all of you. It was a joy having you around here. It's super cool. I really love those live sessions. Last time we did planetary imaging. This time we did deep sky imaging, and that worked out quite good. Yeah, Darko, genau. Just search Dr. Becky. You'll find her. She's the best. Yeah. I thank you all for being here in the chat with me, hanging out. It's such a cool community here on YouTube, and having the the opportunity and to chat with all the folks of you about this cool topic. That's super cool. So I say thank you, and have a nice evening, have a nice day wherever you are, and I will dismount my equipment here and go to bed, and I'm gonna share all the images I took on my social media platform, so just go and have a look. And as Alfred said, if you want me to review your images, or if you want to get in touch or in contact, just contact me over social media platform. That would be super cool. I'll be looking forward to do so. Yeah, have a great night, and as always I say clear skies everyone, until next time here on Catching Photons. Bye bye.